Hello, Mr. Long. This is FRQ number 5. So, part A, we need to find the distance of the board. According to this diagram, really, that's just asking for H max, basically, or to derive it. So, this is the H max formula. And by the way, I will be using, I'll be labeling my degrees because there is 2 angles on this problem. Over to, I'm not going to put G, there's no gravity, this is A. The reason why is because it's on a surface, it's on an incline. It's not like a projectile motion problem where it's like on free fall, it's like flying in the air. This thing is actually stick onto like an incline table. So this is why we put A. And yeah, because it's on a surface, right? So now we need to find A here because we also need data. So we can use Newton's second law. If it goes ma, we can use gx equals ma because there is an angle down there, and that will be if we draw an arrow like down there, that represents our f of g because it's on a surface. I drew another. This represents the angle underneath the table. Nor the top, but that's just for that was the FRQ4 drawing. So if we label this, we can what was it? So that'll be FG drawing down. We have, sorry, that's just F of G. I don't know why there's a F of G is right there. FG X I believe is there, and then FGY, and there'll be a theta right here, which means that this angle is opposite with that angle. So FGX instead of the F cosine, we have F of sine because this is opposite angles, right? This is now on the y-axis instead of the x-axis shown on here. So instead of FGX, we can label it as F sine of theta equals MA. And I'm going to label this as theta 2, represents the angle underneath the table. This will help with organization in the future problem too. And if we simplify this, solving for A, because we need A here, that will be your answer. And then substitute back in the A value that we just got. So sine theta over 2G sine that. That is part A. Now for part E, asking for how long it'll take to reach the target. Okay, so part B, this just kinematics. Instead of like the X, we'll label it as D because it's what the problem wants to label as. So this is just kinematics. AX because it's horizontally, again treating like a projectile motion problem. It's still on the surface though. It's gonna have an AX and AY component because it's shooting up but on the surface. So it's just the kinematic equation VIX because it's horizontal, and I'll cross it out here. I'm gonna cross out this because think of it like projectile. Your acceleration for your X is gonna be 0 the whole time when it goes up because it's gonna land in the same place too, or what was it? They will, land back at the same, I guess, surface, or the height won't change on the V5. It'll land at the same position, but with different distance, really, right? So acceleration would be 0 for that matter. And so we can just say V equals that. Now, for VIX, since we need it in angles, now we can say that is V cosine of theta 1 because now we're not using this angle anymore, we're using this angle right now. So, and that's on the x-axis. So now we can say that our VIX is V cosine. And I put data 1 because there is two different datas. I'm just for organization purposes. So we can isolate to solve for t here, and then t equals the same thing, but this time we can just say v cosine of data 1, and that will be our t. For part C, time reach max height, so we can use the kinematic function again with the vfy equals viy, because the t max will occur on the vertex, so right here basically, and that's determined basically by height, so that's why we use viy or vy, yeah. Minus instead of g, like previous one is not for this, so it's on the surface, so instead of g we'll put at. We can replace the a with g sine of data 2 that we found in part A. And instead of, and vfy will be, that would be 0, because let's draw it like this. If we think of it like a projectile motion, it's going to go up. This right here is your t max. Your vfy here is 0 because it's at the vertex, and the only thing left here is your vix, right? Your x, your vx. Vy fy here is 0 because it's at the vertex. This is the max height, so that's why your viy 0 is 0, or vfy, sorry, not viy, vfy will be 0. So that'll be 0 equals v it's gonna be sine theta, because like what was it? It's on the x-axis, so your y value, your y-axis, according to viy, should be sine, and it'll be via sine of 1 because it's on this angle right here, and we already differentiated. This is data 1, that's data 2. Right, see time data, and I also forgot my t, right, to put the t too. So, and we drew this, and I also forgot to label that I should put t peak here, because this is the peak. This is like at the vertex, and we call that t peak. So if we distribute to solve for t peak, that should equal, if you isolate solve, you should get this value, and the datas don't cancel out because they're two different datas. For part D, we're asked to find basically time total, basically, right? So I guess they label it as, yeah, I can just label it as change t. The time will be to the time, because we already found t peak. This is based on part C, right? We already found that value, which is at t peak, or the time, or the tm according to the problem. I can't really see, but basically part C we found this time right here. We found half of the time in total, right? And in order to find the other time, we have to take this time remaining. So what we just found for part C was this, right? Part D is asking to find the total. So that's just the other half of what we just found here. So then with that, that'll leave it 2 times t. So that's how we got that answer, because part C we found this, part D we want to find the whole thing. So that's just the other half of the time we found. So if we add those together, it's 2 times t. That's pretty self-explanatory too. Part E, to prove that, we will use the range formula. So part E, I can put it right here. Part E is, instead of R, we'll put D because according, that's what the scenario is asking for. Again, over A, that's not free fall. And we can replace A with what we found here, G sine theta 2. And now we just need to isolate and solve for this angle right here. So first we need to do multiply this on the other side. And then divide the v square over. And then after that we need to inverse sine. And to get theta alone, there's a 2 right here, so we just need to move the 2 over via dividing, and that will give your answer. For part E, it's the same value that we're just asked to prove, just like that one right there. Part F, if the angle of the fretboard is increased. By the way, the angle of the fretboard they're talking about is this angle right there. Increase, how the angle part A change. So I'm gonna write part A's expression, aka V max, equals the H max that we just found in part A, which is this right here. And this right here is the angle of the fretboard. They're asking what happens if we increase this. Mathematically speaking, if we increase this angle, this denominator will be bigger. If you divide over a bigger denominator, you get a smaller number mathematically. Because mathematically, that should make sense. It's like 1/2 versus 1/4. One half will be bigger because 1/4, or 1/4 will be smaller because you're dividing by a bigger denominator. Same case like this one, your angle would be increased. Your fretboard would increase, right? And that will increase your denominator. That will lead to a smaller fraction because your denominator is greater than your numerator, and mathematically you should get a lower HX, or the answer that we manipulated for part A, which is right here. So according to that, since the denominator is increasing, we will say this, the denominator is increasing, we'll say that this is decreasing, or the answer to part A should be decreasing. And that is all of FRQ 5. That's what we did. Drawing thingy, whatever. Yeah. Hope you have a good day.